Vectors. That is the topic we're going to talk about right now. That's the Jamaican language. Alright. Now, you probably do physics and, well, you encounter vector and scalar quantities already. But we're going to just review them. Question is, what is a scalar? You're supposed to remember scalar. Scalar are those quantities that have magnitude only, right? You have magnitude only. So, things like time. If you have time, well, the SI unit measure time in a seconds. You have speed, meters per second. You have mass, kilograms, right? You have volume in meter cube. You might have light intensity. You might have energy. Things like those, right? Now, you can say there is a mass of 50 kilogram and the mass up from here so go towards a tree there, or it a point up the road. You can't point your finger and tell which direction the mass act, right? When you say time, a time it take 15 seconds, and the 15 seconds, I don't know if the 15 seconds will go up straight up in the air or it will come down at 60 degrees, but all I know is 15 seconds. That would make no sense because time don't have any direction. So it's a scalar quantity. But when you talk about vector quantity now, vector have both magnitu, magnitude and direction. All right. So, like force, the thing is, if you compare the force and the mass is the amount of matter in an object, right? Now, the force, an example of force is weight. Weight is really the force that any object exerts on any other object near to it. That weight is due to gravity. Every object have gravity, Even one rock stone you see at the side of the road, that itself have gravity. If you go up in a space and put two rock stones beside one another and let them go, after a while you see them come together because they pull one another together. Because both of them have gravity and gravity pull each other. Your body have gravity and the earth have gravity. So while the earth pull you, you also pull the earth towards you when you jump up in the air. Right? Now, the thing is, say you stand up here so on top of the earth. Now your mass are the same. If you go up in a space, you have the same mass, but you're going to have zero weight depending on where you're going in a space. If you go up on the moon, you have about 1/6 the weight we have here. Right? If you weigh 180 pounds on the earth, you're going to have about 3, 6, 18, about 30 pounds on the moon. Right? And one spacecraft far away from the earth and the moon, you probably won't weigh anything. You're going to have zero weight. Because Your weight is a force. No, the thing is, your mass, it might be how many kilogram, but say 70 kilogram or 80 kilogram. Your weight is the force that the earth pull you towards it. And of course, the force that you pull the earth towards it. But you hardly pull anything compared to what the earth pull. So we're going to just say, is the force that the earth pulls on you towards it. So that is the weight. And it act, well, if you stand up and you point down, you have the direction of that force. So you have magnitude and direction. So you would have a force of 180 pounds. That's the magnitude, you know. Downwards, that is the direction. Alright, so those are magnitude and direction. Alright? So those are scalar and vector quantities. We're going to talk about representation in the next video.